Alright, welcome back. So we are moving into the third video for this chapter. We're going to be talking a little bit about the cognitive approaches to recognition. In other words, how we start forming what these objects are. A very quick run through of basic feature recognition. There are two kind of ways that people think about it. One is template matching, and I'm going to go ahead and kind of spoil this for you. Template matching is not the most commonly accepted version of object recognition or feature recognition. That template matching is essentially the idea that whenever we recognize something is because we have learned a template for what that feature is or what that object is, and we are matching that feature that we are currently seeing with something we've already learned. So to give you an example, what you are looking at here, where it says template, you can see all these circles, you can think of these as kind of like, I don't know, rods and cones. So these are parts of your retina. And so if you have this A that is on this retina, and it corresponds with you learning that on your retina, whenever you have seen that in the past, that is the letter A, then you will recognize that as the letter A. So that the letter L, for example, is not going to activate these same photoreceptors, and consequently, these same parts of the primary visual cortex, and so we don't recognize this as an A because it doesn't line up with this specific template. But it does line up with our template of the letter L, and so on. But there are some problems with this, and the problems with this, and there are many, is essentially that this means that we would need to learn hundreds of thousands of infinite numbers of templates. Why? Because if you look, for example, at this A over here in panel D, it doesn't align perfectly with this template. So we would need a template for this specific A to recognize that this is an A. Just like this A, this A, this A, and this A. They're all slightly different. We would need templates for each of these to be able to recognize that they are all A's. That doesn't seem very likely given how much space we have in our head. I'm just going to skip over that. We have developed machines that have tried to use this specific type of learning, this specific type of feature matching, that we match templates to things. And a lot of early text recognition software would do this. It would learn all these different fonts, and then whenever you would scan in a PDF or scan in a Word document, it would kind of go through and it would recognize all of that text in your book or whatever. That's because it had all these templates that allowed it to quote-unquote read what was there. But we know that there's problems with that because you have used, or let me backtrack. We know that there are problems with that as an explanation for human perception. And we know this because most machines can't beat that stupid CAPTCHA internet security thing. And you know what I'm talking about. These right here on the right hand side where you're trying to log in to a website and you have to try to spell out what these things are. Why do they get you to do that? They say it's to prove that you're human, right? Because humans are very easily able to say SSMP7T or 77ZLM or N, excuse me. Sorry, I'm not human. But machines have a much harder problem with that because these do not easily match any of the templates that are preset or organized for the software. So we would need a near infinite number of templates in order for this to really work for the human mind. So template matching, even though it was a very popular theory for a very long time, is no longer kind of the lead one now. The one that's more commonly accepted these days is called feature analysis. If you take cognitive psychology, you'll learn more about this in chapter 3. Those of you who had me last semester may remember that. So feature analysis is essentially that we don't remember templates, that we don't organize our perception with templates. Instead, we do it based on different combinations of features, different ways in which these lines share some kind of relationship with one another. So, as an example, just to use the letter A one more time. Previously, we said that that A needed to match that specific template. Here, what we're saying is that instead, what our brain is going to be looking for is like, oh, we have cells that are firing for a diagonal line, for another diagonal line that's in the slightly different direction, and then for a horizontal line. And if those cells that are firing for those particular lines are close enough to one another, we perceive that as the letter A. And so this is part of the reason why we are very prone to making mistakes whenever we have letters that share features. So for example, very commonly when people are reading, they might mistake C and G, or B and D, or the lowercase e and the lowercase a. And the reason for that is because these letters share a lot of the same features. So because of that, excuse me, because of that, we recognize a lot of these features in kind of the same, and they have kind of the same relationship, but it basically gives us a false alarm that it is telling us that it is something that it is not. So that's feature analysis. This seems to be much more likely than template matching theory. It doesn't require a near infinite number of templates in order for us to do this. Instead, all we need to learn is that there are certain kinds of, in this case, letters, shapes, objects, whatever, that have these different kinds of patterns, these different kinds of relationships with these rudimentary lines and contours. Alright, so that's feature recognition. Now let's talk a little bit about object recognition. So we're moving our way up. We're getting broader and bigger. So the main theory here is object recognition, is recognition by components. This was put forth by Irving Biederman in 1987. So this theory is older than me, but it has held up. It has stood the test of time. With lots of people replicating this study, lots of people testing this study. It seems to be that this is kind of how the human mind works when it is recognizing objects. So there are 3 stages to this theory that Biederman put forth. Basically, he's saying that when we are recognizing objects, that what we are doing is we are going to be recognizing first the sub-objects of that larger object. So if we are thinking about, for example, a horse, or an ostrich, we look at this horse, and what our mind is going to do, and again, this is very fast, it's within 150 milliseconds, remember, that what we're going to do is we're going to recognize the individual components of this horse first. We're going to recognize its sub-objects, the objects that make up this horse. So we're going to break it down into basically its head, its neck, its shoulder, its limbs, its torso, its tail, etc. So that's, the first step that we have here. And the same with an ostrich. We're going to recognize, all right, head, neck, body, 2 legs, kind of a tail. You got it. The second stage then is that we're going to take those sub-objects, the neck, the legs, etc., and we're going to classify those into different categories of geons. And what a geon is short for geometric ion. You can think of it as basically the most simplest version of a shape that you can get, of a 3-dimensional shape that you can get. So for example, this is a cylinder. Can you break this cylinder down into being something even more simple than a cylinder? Not if you're going to keep it in 3 dimensions, right? You could say that, oh, there's a circle here, but that would have to be flat. We're talking about 3 dimensions. So a cylinder, a cone, a pyramid, football, a horn, you get the idea. There are 36 different geons that have been classified that basically our minds very quickly recognize in these patterns. So, for example, we're looking at the horse. So the first thing that we're going to do is, again, we're going to break it down into its geons, into these sub-objects. We're going to recognize, all right, the head looks like a cylinder, or is the cylinder shape maybe kind of a cone shape almost. The neck is kind of a cylinder. The torso is kind of a cylinder. The legs are certainly kind of cylinders. You get the idea. So we're recognizing what these sub-objects are after we've broken it down. And then the final piece of it is going to be that we recognize what these geons, what relationships they have. So what's the word I'm looking for? Can anybody help me? What's the word I'm looking for? That we recognize the pattern. We recognize, I already said relationship. I'm struggling for the right word. I apologize for that. But we're looking for the way that these objects are related to one another, whether they're close to one another, how long they are, how thick they are, because that can tell us exactly what we're looking at. So we're looking at what kind of patterns they have together. So what does that mean? basically, if we're looking at this horse, if you break up this horse into its sub-objects, you'll quickly find that it has the exact same sub-objects as a dog or as a giraffe, right? But whenever you first saw this horse, you didn't mistake it for either of those, right? And the reason why is because what we're recognizing is the pattern in which those geons share. So, for a giraffe, we would recognize this geon specifically to be very long, right? And we don't see that with the horse, so we know it's not a giraffe. For a dog, we would expect certain kinds of ears, certain kinds of tails. Its legs would not be this long. And so we would basically need those geons to be those appropriate sizes and shapes and width for us to categorize that as a dog. I hope that makes sense, because again, we can look at the sub-objects of an ostrich, and it has the exact same ones as a dove or as a pigeon, but they're just in different proportions. They have a different relationship with one another, and that relationship is going to tell us what that specific object is. Alright, so that's pretty much it for object recognition. The next piece that we have here is going to be about face perception, so about recognizing faces, and actually I'm going to save that for the next video that will conclude this chapter. So stay tuned for the breathtaking finale of object recognition, chapter 4. I'll see you soon. Bye.